problems involving arithmetic sequences. Problem number 1. The fourth term of an arithmetic sequence is 19, and the 12th term is 51. Find the ninth term. The formula for arithmetic sequence is a sub n is equal to a sub 1 plus the quantity n minus 1 times d. Substitute the data in the formula. The problem says the fourth term of an arithmetic sequence is 19. So n is 4 and a sub n is 19. So we have 19 is equals to a sub 1 plus the quantity 4 minus 1 times d. A sub n is 19, n is 4. Let us continue reading the problem. And the 12th term is 51. So n is 12 and a sub n is 51. So we have 51 is equal to a sub 1 plus the quantity 12 minus 1 times d. A sub n is 51, n is 12. Let us simplify the two equations. 19 is equal to a sub 1 plus 3d. 4 minus 1 is 3. 51 is equal to a sub 1 plus 11d. 12 minus 1 is 11. In 19 is equal to a sub 1 plus 3d, we have two unknowns, a sub 1 and d. In 51 is equal to a sub 1 plus 11d, we have also two unknowns, a sub 1 and d. Since the two equations share the same variables, we can treat them as a system of equations. Solve for the common difference d. In the problem, we don't know the first term and the common difference d. Let us solve first for the common difference d. The first equation in the system is 19 is equals to a sub 1 plus 3d. The second equation is 51 is equals to a sub 1 plus 11d. Let us eliminate a sub 1 and a sub 1 here. We can do that by multiplying the left side and the right side of this second equation by negative 1. So 19 is equals to a sub 1 plus 3d. Negative 51 is equals to negative a sub 1 negative 11d. So positive 51 became negative 51. A sub 1 became negative a sub 1, and positive 11d became negative 11d because we multiplied the left side and the right side of this equation by negative 1. Positive 19, negative 51 is negative 32. Positive a sub 1, negative a sub 1, 0. And then positive 3d, negative 11d, negative 8d. Divide both sides by negative 8, the coefficient of d. And then 4 is equals to d, or d is equals to 4. So the common difference, d is equals to 4. Next, solve for the first term, a sub 1. We can do this by substituting the value of d, the common difference, in place of D in the first equation of the system. So 19 is equals to A sub 1 plus 3D. We know already the common difference D, it is equal to 4. So substitute 4 in place of D. So 19 is equals to A sub 1 plus 3 times 4. So 19 is equals to A sub 1 plus 12. Transpose the 12 to the left side and change the sign. 19 minus 12 is A sub 1. And 19 minus 12 is 7. So 7 is A sub 1 or A sub 1 is 7. We can now solve for the ninth term. The formula for arithmetic sequence is A sub n is equals to A sub 1 plus the quantity n minus 1 times D. So replace n by 9. A sub 9 is equal to 7. Our first term is 7. And then n by 9. And then 9 minus 1. And then replace d by the common difference, which is 4. Then just do the indicated operations. So this is the 7 plus 9 minus 1 is 8. Then times 4. So 8 times 4 is 32, and then 7 plus 32 is equals to 39. So the ninth term is 39. Problem number 2. Find x such that 1 minus x comma 14 is an arithmetic sequence. Let us first represent the first term by A sub 1, the second term by A sub 2, and the third term by A sub n. The value of n is equal to 3 because there are 3 terms, so n is equal to 3. The common difference is A sub 2 minus A sub 1. So D is equals to A sub 2 minus A sub 1. But A sub 2 is x and A sub 1 is 1 minus x. So we have x minus the quantity 1 minus x. Remove the parentheses. So we have x minus 1 plus x. The parenthesis is preceded by a minus sign. So 1 is negative 1 and negative x becomes the positive x. And then simplifying, we have d is equals to 2x minus 1. The formula for arithmetic sequence is A sub n is equals to A sub 1 plus the quantity n minus 1 times d. A sub n is equals to 14. And A sub 1 is 1 minus x plus n is 3, so 3 minus 1. Then times d. D is 2x minus 1. So we have 14 is equals to 1 minus x plus 2 because 3 minus 1 is 2 and then 2x minus 1. So we have 14 is equals to 1 minus x, then 2 times 2x is 4x, 2 times negative 1 is negative 2. So we have now 14 is equals to 3x minus 1. 3x minus 1 because positive 4x, negative x is 3x, and positive 1, negative 2 is negative 1. Transpose negative 1 to the left side, then add it to 14. And 14 plus 1 is 15. So 15 is equal to 3x. Divide both sides by 3. So x is equal to 5. So what is the sequence? The first term is 1 minus x, comma 14. 1 minus 5 is negative 4, and then x is 5, and then we have there 14. So this is the sequence. Negative 4, 5, 14. It's the same problem. Find x such that 1 minus x, comma 14 is an arithmetic sequence. Another solution. We are going to apply the formula for finding arithmetic mean. A sub m is equals to a sub 1 plus a sub 3 over 2. A sub m is the middle term, which is x, and then a sub 1 is 1 minus x, and then a sub 3 is equals to 14. So we have x is equals to 15 minus x over 2, 1 plus 14 is 15. And then cross multiply. We have 2x is equals to 15 minus x. Transpose negative x to the left side and change the sign. And then add it to 2x. You get 3x is equals to 15. Divide both sides by 3. So x is equal to 5. Still the same problem. Find x such that 1 minus x, comma 14 is an arithmetic sequence. Another solution. Find the difference between the second term and the first term. That is x minus the quantity 1 minus x. And then the difference between the third term and the second term. That is 14 minus x. So we have x minus the quantity 1 minus x, and then 14 minus x. Remove the parentheses first. So we have x minus 1 plus x is equal to 14 minus x. So x plus x here, we have 2x minus 1 is equal to 14 minus x. Transpose the negative x to the left side, change the sign. Transpose negative 1 to the right side, change the sign. So we have 2x plus x is 14 plus 1. And then 3x is equals to 15. Divide both sides by 3. So x is equal to 5.